In this video, we're going to be learning about functions. Functions are one of the most useful ideas in mathematics because functions govern many interactions in our society. Whether you're buying a cup of coffee at a coffee shop or if you're playing a video game, all right, you're using a function in some fashion. All right, our definition of a function. All right, a function is a rule or a relation that assigns to each input exactly one output. That's the key here. To be a function, every input can only have one output. If an input has more than one output, then the relation would not be considered a function. Okay, so before we get into some examples of functions, one thing that I want to talk about is different types of variables that are involved in our functions. There are two types of variables to consider whenever you're looking at a relation. One of them is called the independent variable. The independent variable's value is not changed by any other variable. The independent variable's value can be whatever you want, all right? That's why it's independent. On a graph, the independent variable is always located on the x-axis. All right, and the independent variable, the x-axis values, represent the input values of a relation. Okay, so x represents the input, it's the independent variables. The other variable is called the dependent variable. All right, and the dependent variable's value is influenced by other variables. It depends on the value of something else. On a graph, this is always located on your y-axis, all right, and it's going to represent the output of the relation. Okay, the output depends on the input. Okay, so that's why it's going to be your dependent variable. So the independent variable, your x variable, is the input. Your dependent variable, the y variable, that is the output in a function. Let's see if we can look at some relations and see if they see what the independent and dependent variables would be. In our first example, it says that Megan is buying bagels for a family gathering. Each bagel costs 75 cents. What is the independent variable? What is the dependent variable? Well, in this example, the independent variable is the number of bagels purchased. All right, Megan can buy as many bagels as she wants. That's why it's the independent variable. The dependent variable is the total cost. The total cost is the dependent variable. The cost is going to depend on how many bagels that Megan decides to buy. In example B, Mr. Burns is renting buses for a school trip. All students are invited on the trip. What's the independent variable? What's the dependent variable? Well, the independent variable in this example is the number of students attending. Okay, the number of students attending the trip is the independent variable. They can have 5 kids attend the trip, they can have 100 kids attend the trip. All right, the total number of students is independent. What is dependent, though, the dependent variable is the number of buses. All right, the number of buses that are rented depends on how many students are going on the trip because you have to have the correct number of buses for the total number of students attending the trip. In example C, the amount of time Mike spends studying for his math test. What's the independent variable? What's the dependent variable? Well, the independent variable is the time spent studying. All right, time is the independent variable. Mike can study for as long as Mike would like to study. All right. The dependent variable is Mike's test grade. All right. The grade that Mike gets on his test is going to depend on how well he has prepared himself. So, how long he has spent studying. So, the independent variable is your time, and the dependent variable is the test grade. All right, so we talked about relations and functions a little bit earlier. A relation is a set of input and output values represented as an ordered pair. An ordered pair, remember, is x comma y. Your input values, we said, were the independent variables, which is x, and your output value is the dependent variable, which is going to be y. All right, so a relation represents these as ordered pairs. A function is a relation where each x value, the input, is paired with only one y value, the output. All right, if your input is paired with more than one output, then it will no longer be considered a function. What we want to be able to do is identify functions. All right, that's the main purpose of this video. Relations are represented as ordered pairs, but can also be represented with tables, mappings, graphs, and equations. We're going to look at each of these examples throughout the unit. All right, the important thing to remember is that for a relation to be a function, each input has exactly one output. So let's take a look at an example of this. Example 2. Determine if the relation is a function by making a table, a mapping diagram, and a graph. So here's our relation. Again, a relation is just a collection of input and output values represented as ordered pairs. So we have 3, 5, 2, 1, 1, 4, and 5, 5. Let's create a table of values from these points. All right, the table is going to consist of x, the input values, and y, the output values. All right, and we can even write that above. The input values and the output values are the y values. Okay, so looking at my first point, the input 3 maps to the output of 5. The next input 2 maps to the output of 1. The next input 1 maps to the output of 4. And the last input 5 maps to the output of 5. All right, so looking at this right here, all right, to be a function, every input can map to only one output. So if I look at my inputs, all right, there's only 1, 3, and it maps to one number, 5. My input 2, there's only 1, 2 in my input, it maps to one number in the output. In my input, there's only 1, 1, and it maps to the output of 4. There's only one output for that number. The input 5 maps to only one output, which again is 5. So by looking at this, I know that this will be a function, okay? This is a function because each input maps to only one output. All right, each input x maps to only one output y. All right, we can make a graph of what this function would look like. Now here we're in quadrant 1. This is your x-axis, this is your y-axis. So this right here is the origin. The first point is 3, 5. So I'm going to go to the right 3 and up 5. There's our first point. Our next one is at 2, 1. So to the right 2, up 1. Our next is 1, 4. To the right 1, up 4. And our last one is 5, 5. To the right 5 and then up 5, right about there. And there we have it. So these 4 points represent what this relation, what this function looks like. A little bit later, we're going to talk about how we can look at a graph and determine whether or not the graph represents a function. One other thing that we can do with a relation is create something that's called a mapping diagram. A mapping diagram is drawn using 2 ovals. The first oval represents the domain of the relation, which is the input values. The second oval represents the range, which is the output values. Arrows are then drawn from each input value of the domain to its output value in the range. We're going to create a mapping diagram for this relation found right here. So let's go ahead and create our mapping diagram. We're going to write the words domain and range. And then we're going to create 2 ovals. So something like that and something like that. Okay, and now what we're going to do in each of these ovals is list the numbers that are a part of the domain and the range. So remember that your domain is the input values, which again is your x values right here. So all of the numbers that are these inputs are part of the domain. So your domain is going to be the numbers 3, 2, 1, and 5. So let's write those in there. 3, 2, 1, and 5. Your range values are the output values, which are right here in the Y column. All right, your output, your range values are 5, 1, 4, and 5. Notice that 5 is listed twice in the table. When we write it in the range, we're only going to list it once. Okay, so there are actually only 3 members of the range, and they are 5, 1, and 4. Now what we do, we take each member of the domain and we map it to its corresponding value in the range by drawing an arrow. So my first point, 3 maps to 5. So I'm going to draw an arrow from 3 in the domain to 5 in the range. My next one, 2 in the input or the domain maps to 1 in the output or the range. 2 maps to 1. Our next one in the domain maps to 4 in the range. 1 maps to 4. And then in my last one, all right, 5 maps to 5. 5 in the domain maps to 5 in the range. And there I can see clearly that each one of these numbers in the domain, each of these input values, only goes to one specific output or range value. So again, this is a useful diagram in showing us that this is a function. In our next example, we're going to practice determining if the relation is a function. We're going to do that by making a table, a mapping diagram, and a graph. So our relation has these ordered pairs, all right? Again, a relation is a collection of input and output values represented as ordered pairs. We have 1, 1, 2, 3, 3, 4, 4, 5, and 3, 0. All right, we're going to have our input X and our output Y values. Let's go ahead and list those. All right, for the input 1, the output was 1. For the input 2, the output was 3. For the input 3, the output was 4. For the input 4, the output was 5. And for the input 3, the output was 0. All right, so let's plot these points on the graph. 1, 1, here's the origin. I'm going to go right 1, up 1. 2, 3, I'm going to go right 2 and up 3. 3, 4, I'm going to go to the right 3 and up 4 units. 4, 5, I'm going to go right 4 and up 5 units. And then 3, 0, I'm going to go to the right 3 units and stop. Okay, so that's what our relation looks like as a graph. And then the other thing that I'm going to create is my mapping diagram. So I need my domain values and I need my range values. Draw those ovals. Okay, and let's list the numbers in the domain. Again, the domain is the input values, which is the X values, 1, 2, 3, 4, and 3 appears again, so we're not going to list it. So just 1, 2, 3, and 4. 1, 2, 3, 4. The range values are your output values, which are the Y values, 1, 3, 4, 5, and 0. None of those numbers show up more than once, so we'll put them all. 1, 3, 4, 5, and 0. And now we're going to draw arrows to map the domain value with its range value. 1 in the domain maps to 1 in the range. 2 in the domain maps to 3 in the range. 3 in the domain maps to 4 in the range. 4 in the domain maps to 5 in the range. And 3 in the domain maps to 0 in the range. Okay, so looking at the table, the graph, the mapping diagram, we should be able to tell whether or not this is a function. And what really gives it away is in the mapping diagram. If I look at this number 3 in the domain, notice that 3 maps to 2 different numbers. All right, 3 maps to 4 and 3 maps to 0 as well. In my input values, 3 maps to 4, 3 maps to 0. One of my input values maps to 2 different output values. One of my inputs maps to 2 different outputs. This is not a function. Okay, this is not a function because a number in the domain maps to more than one number in the range. Okay, if there is a domain value that maps to more than one range value, then this is not a function. All right, there's one input that has more than one output, making this not a function. In my next example, I want to know from this graph, do the points on the graph represent a function? Okay, so you can look at the graph and see that we have 5 different points that have been plotted. I want to know if that is a function or if it's not a function. Okay, so what I can do is actually look at each point and determine its coordinates. So this point right here is at -1, 3. All right, and then this point down here is at 2, -2. And this point here is at 4, -1. And this point here is at 3, 2. And then this point up here is at 4, comma 5. All right, and what I can do now that I've got my relation here, all right, my collection of ordered pairs, let's create a mapping diagram. So we're going to have our domain, we're going to have our range. Let's go ahead and create that mapping diagram. All right, so again, the domain is the x values, all right, the input values. We have -1, 2, 3, and then 4 shows up twice. So we're going to have 4 there in the domain. So -1, 2, 3, and 4 are the domain. The range values are the output values, which are the y values. We have 3, we have -2, we have -1, we have 2, and we have 5. And now let's go ahead and draw arrows to map the domain values to their range values. -1 maps to 3, 2 maps to -2, 4 maps to -1, 3 maps to 2, and 4 maps to 5. All right, and looking right here, well, again, notice that we have a number in the domain, your input values. We have an input that maps to 2 outputs. It goes to 2 different numbers in the range. So this relation is not a function because there is a number in the domain that is paired with more than one number in the range. Okay, so said another way, there is an input value that has more than one output value, and that makes this not a function. Okay, now there is another way to tell just by looking at the graph that we're going to talk about here momentarily. I actually didn't have to create this mapping diagram here. If I just looked at the points on the graph, I could tell that this is not a function. So let's talk about that next. When working with graphs of relations, a special test known as the vertical line test can be used to determine if the relation is a function. All right, for the vertical line test, if any vertical line passes through the graph of a relation no more than once, then the relation is a function. Okay, so any vertical line that you draw through a relation can only hit the graph once, and if that's true, then you have a function. If your vertical line hits the graph of the relation in more than one spot, then it would not be considered a function because that means that there's an input value that would map to more than one output value. All right, and we can see that in our previous example. All right, this was the graph that we had looked at where we had our 5 different points on it. And we saw right here that the number 4 maps to the numbers -1 and 5. Now remember, your domain here, these are your x values, okay? So those are the x values, those are the y values. So that means if we go to where x equals 4, 1, 2, 3, 4, all right, right here. And if we draw a vertical line through this point here, then that vertical line is going to hit two different parts of the function, or the relation, I should say. It hits the relation right there at 4, 5, and it hits the relation there at 4, -1. This input value 4 maps to two different output values of 5 and -1. Therefore, this vertical line hits the relation in two places, so this is not a function. All right. Looking back at the one that we did before that, we also said that the domain value, your x value of 3, mapped to two different output y values. So let's find where x equals 3. Here's the origin, 1, 2, 3. If we draw this vertical line right here, all right, this vertical line right here hits the point, hits the relation in two different points, right there and right there at 3, 0 and at 3, 4. So this also is not a function because it fails the vertical line test. If we look at one of our earlier examples, all right, this example right here, we said this is a function because each input maps to only one output. All right, every one of these inputs maps to only one output. That means if I draw vertical lines, I'm only going to hit the relation in one spot. This vertical line hits the relation only once right here. This vertical line hits the relation only once right here. This vertical line hits the relation once. This vertical line hits the relation only once. If the vertical lines hit the relation only once, then it passes the vertical line test, and you know that you are working with a function. But if any vertical line hits the relation in more than one place, then it will fail the vertical line test, and it will not be a function. What we're going to do now is use the vertical line test on some graphs of relations, and we're going to see if those relations can be called functions. Again, we have to use the vertical line test. If the vertical line only passes through the graph of the relation no more than once, then we know we're working with a function. So for each of these graphs, what we're going to do, we're going to draw 5 different vertical lines. Okay, so 1, 2, I'm actually going to use this axis as one of them, so that can be the third one, 4, and 5. And what I'm going to do is look at each vertical line and tell how many times it hit the relation. All right, this is the relation right here. So this vertical line hits once right there. This vertical line hits once there. This vertical line hits once there. This vertical line hits once there. And this one hits once right there. Every vertical line hits the relation only one spot, so this is a function. Okay, here's our relation this time. It's this curved piece right here. Let's draw in some vertical lines. So again, I'm going to use this as 1. All right, so here's a second, here's a third, here's a fourth, here's a fifth. All right, this vertical line hits the relation in one spot right there. This vertical line hits the relation in two places, there and there. This vertical line hits in two places. This vertical line also hits in two places, as does this vertical line. It hits in two places. We have many vertical lines that hit in more than one place on my relation, so this is not a function. This one failed the vertical line test. Down here, this is our relation. Let's draw in some vertical lines. So again, this can count as 1, 2, 3, 4, 5. All right, this vertical line hits the relation once here. This one hits the relation once here. This hits the relation once here, and once here on this vertical line. Each of these vertical lines hits the relation in only one place, so this is a graph of a function. All right, and finally, we've got this curved piece right here. This is called a parabola. And again, we're going to use the vertical line test to see if it's a function. So here's one vertical line, Here's a second, a third, a fourth, a fifth. All right, this vertical line hits the relation once. This vertical line hits the relation once. This vertical line hits the relation once, as does this one. And this vertical line hits the relation once as well. Every vertical line hits the relation only once. So again, this is the graph of a function. It passed the vertical line test.